according to the textbook I'm looking at, it's at chapter 11 in the textbook. And one of the reasons I've got the textbook out is there's quite a lot of specific names for specific exam boards. So I must have about 4 textbooks next to me for each exam board here, for when I film all these videos. As well, I have the Casio ClassWiz, this calculator right here. I'll be using that because, as we're going to look at today, I'm going to look at the world of vectors. Now, the trouble with vectors is because it splits up into so many areas of maths. In further maths, you'll learn about the scalar product. Now, the scalar product, I'm not going to teach in this video. The scalar product, I'm going to put in a separate video. Now, that probably might be out before this or after this, depending on how I film this. So, what we're going to look at is the basic vectors. Now, if I had, for example, from the GCSE stuff, we said that if we had a vector A, at point A, and we had a vector that way B, we could find what AB was, which was just A plus B. Okay? So we could use that. However, that doesn't work so well when we look into our A-level knowledge, because vectors have their certain properties. Okay, so for example, A to B, we now write it as B take away A, because you go up from B and then you go back along the vector, so it becomes negative and it becomes a negative A. Okay, right. So this is what I'm using here, A to some point I could call the origin, and then down to here, that's B, take away A, yeah? This is what's called the triangle law. Okay, when we're adding vectors together, that's the triangle law. Okay, now, if we had a vector P of A plus a vector Q of B, that is equal to some R of A plus some S of B. And that would say that P is equal to R and Q is equal to S, which is quite useful when we get into some vector problems. I'm not going to cover vector problems as such in this specific video. You'll see them in another video that's coming soon. Hint, hint, there is another video coming soon. Right, the next thing I want to look at is lengths of lines. So, if we wanted the modulus of AB, well, if you think about it, if I take the right angle triangle, that's A, that's the origin, that's to B. O to A could be of length 4, that could be of length 5. Now, the only problem with vectors at A level compared to GCSE is you'd have to write them in component form. Component form is I and J notation. So this would be 4I plus 5J. Okay, make sure you underline all of your vector notations into 3 dimensions. That would, you could have 4I plus 3J plus, I don't know, 2K. Okay, that would also be in 3D. That's in 2D, that's in 3D, it's just got the extra bit on it. Okay, so the modulus then, well, the modulus is using Pythagoras' theorem, A to B. So AB is equal to the square root of 4 squared plus 5 squared. Which is why I said you need a calculator out. So if you've got your calculator, put the square root of 4 squared plus 5 squared, you get root 41. So that is the length of this vector. Okay. Also, I would probably suggest of looking at what I've got here in the textbook. So if we had, for example, lambda lots of some vector with points P and Q, that is lambda P lots of lambda Q, multiplying it by the scalar, in a sense, where lambda is a scalar. Basically just a number, in a sense. Okay, so we're building up this knowledge. we're slowly getting to a point where we can bring up some proper tough sections. Now, I am actually going to bring in the textbook for this next bit in a second. So I, in vector form, will go 1 in the x and 0 in the y. So I should be 1, 0. J is a vector 0, 1. So this is where we get our identity matrix. For those that do further maths, we get 1, 0, 0, 1, the 2 by 2 identity. As such, I2. So we'll bring in that as well when we look at transformations using matrices in further maths. But for us in single maths, we're going to take this a little bit further. So if we wanted a hat, now a hat is the unit vector. Now a unit vector is of length 1. So we're getting a vector on its own. Well, that's just the vector divided by its length. To get it in terms of length 1. Okay, so AB is a hat. So the unit vector A to B, with a hat on it, will be the vector divided by its length, root 41. Okay? We see where this is coming from? So raise that. So we can see where we're picking this idea up of vectors. Now, vectors have directions with them, as we know. The scalar is just a number. Also bring in that point. One other bit that you'll learn at GCSE, which is kind of the first section that you need for A-level, for the single A-level maths, in the second year, we'll step this up a little bit further. I might cover that in this video as well, just to make sure this video is complete. Or I'll put it as a separate video. I might end up putting it in a separate video. So the other bit we're going to look at is finding, for example, vector A, vector B, some point on the line M, and I could say that A to M is 1/3 of vector A to B. Find M to B. Okay, and I'll say that is vector A to B. Okay. So what would A to M be then? Well, A to M, as I've told you in the question, is 1/3 of the vector AB, which is A on its own. So a bit like that. Well, M to B, if this is a straight line and the points are collinear, meaning they lie on a line, so M to B will be equal to 1 take away A to M, which is 1 take away 1/3 A, which is just 2/3 of A, and that would be M to B. So it's using a ratio, so it could be, for example, 1 to 4, which means there are 5 parts, so that'll be 1/5 parts, that'll be in 4/5 of parts, and then you could work with those and multiply them by your vectors. Pretty simple stuff, really, in the first year of A-level maths anyway. So the last bit, I'm going to actually bring in a textbook. So if you're wondering, I'm using the Excel textbook, you can see that. I'm using the Year 1 book. I'm just going to write this down and then we'll annotate bits of it, so we can see where this is coming from. Okay, so O to P, given that P is a point P on a line, Right, thank you textbook. Okay, so this is what I was going on about. So O to P is O to A plus some lambda of the ratio of this line, which is kind of what I was talking about there, but I just wanted to get it from the notation that the textbook uses just to make sure it's proper, on point, and we can go along with it. I'm not giving you incorrect information. Okay, I don't want to give you incorrect information, that's not ideal. So what we're saying is, we can find any point, we can find basically any point on a vector using how we know the lines are related to each other in terms of their points. So, for example, what I was saying there, a point M, point A, and a point B, that there could be 1/3, which means that would be 2/3. Okay. The ratio could be in a ratio of 1 to 2. Okay, so these, if you add them up, will give me 3. So do 1 divided by how many there are, and that will be 2, so how many there are. Yeah? So that's pretty much what you need to know for your vectors in signal maths. I'm not really taking this as much as I would like to because of time. This video will be cut short. In the next part, in a separate video, I'm going to film the scalar product, in a sense. Now, scalar product is in A-level further maths, so if you do further maths, stick around because I will put that video up and then we can have a look at that. Okay? So next up, I'll do the scalar product, but if you're just doing single maths, you can leave this video here, go do some practice questions in the textbook. Thanks very much for watching, I'll see you next time, goodbye.